Alright, I think we're live. We're live? Good enough. The lighting's all okay, but it seems dark. Let's scan this in. Sort of cover up some personal data. Hey Swindon, I thought you were streaming actually. Did you just finish? Yeah, there it is. Hey Rusty Russ. Yeah, all sold out. I'll be making some more today, which is what I'm doing right now. Well, after I've sorted out the Mac. They certainly sell out faster than I anticipated. Okay. Make sure there's... Okay, cool. Just realised I haven't even stickered this thing up. Hey, Mr. Lockpicking. Okay, definitely casting shadow here. Oh well. Time to sort the lights out another time. And we need to just wash this down a little bit. Yeah, I'm starting to find that I really cannot afford to do streaming at night. There's too many things that can happen. I need to... last night after I finished that stream we had to race around the yard because a foreign cat managed to actually get in, so which is a whole new concern on its own. Yeah, it's a lot harder at night, so I'm just going to have to start doing this stuff during the day. Alright, what's going on here? Machine has faulty motherboard, client would be after data if possible. Okay. Let's see what kind of issue it's having. Need a mascot cat. Geez, I've got a gazillion choices there. So we've got 200 milliamp, drops out, restarts, spike of half an amp. It's going to drop out and restart again. Yeah. Alright. Interesting. And by interesting, I mean I can't think of anything off the top of my head that would behave like that. John. Okay, well. Very puff battery. Oh. Brilliant. So this has been pre-worked. 2608. There was no indication that I recall. No indication that this has already been pre-worked on, so... Where's the battery screw? You know, what if I needed that battery screw? Nothing's connected. No, we're just going to take the board out. This is a bit of a mishmash. This is why I really don't like... Well, this is why a lot of us don't like prior repairs. At least not without some sort of additional financial penalty. I mean, it's not to say that all prior repairs are bad, but it does add a level of complication. And we're also missing the battery flex. Where the hell's the battery flex? Ah. No apparent marks on the bottom, so there's a spot of corrosion there. Okay. Guess we'll just give it a visual check, see what's going on. Hey, Tom Morgan. I'm really not sure what I'm going to be looking for. It could be maybe a failed 3v8. Yeah, I'm going to say Wi-Fi is the killer here. I'm going to guess one of those caps is cracked up there. Let's see if we've got a short. Okay, no short there. I think that short was just me. No, it wasn't me touching that. Yeah, I think this, what's going on here? I sort of sometimes get a beep, sometimes don't. I'm going to have to cut away some of that underfill just so I can get a slightly better access. So we're only doing 230 here. That's the best dentist appointment time too. If you're wondering, like 2:30 dentist, hopefully a few of you will get that. Yeah, but that happened sometimes, but it kept coming back at me, so the fact that it kept coming back at me is making me want to dig in more. Like, if you get it on the first time, yeah, you expect that, but repeatedly, that's a little different. It is the edge. I was touching the edge. Yeah, okay. That's okay. It need to be inspected regardless. Okay, we'll just keep those in mind anyway. Certainly a lot of junk. This is the 3v8 generator. Okay, let's check top side. Another reason why I tend to do this a lot is because there is a good number of times that you want to go back and look over a board. So like you've forgotten something, or you just want to check on a video reference the condition of something before you started working on the board. And so by having it all scanned in with the microscope camera, you can always refer back. This is the most common area for these machines to get hit with liquid damage, but that doesn't appear to be the problem here today. Which is a bit concerning in its own right. Kind of wonder if the daughter board was a problem. We'll just put a connector up on this and see what happens. It'd be funny if it was just the daughter board. Yeah, Chrysalon, that is the situation. You're like, okay, I really would like some kind of filth and corrosion, because if it's not that, then it's usually a pain in the backside fault. Like I said, we've got this half amp spike roughly, and then, yeah, nope. It's not the daughter board. Okay, I'll take an angled look at the board and see if we can find any crack caps. That's 5VS2 generator, but we're not even getting to that stage. And I don't think it's a... You can see that little bit of corrosion there, just sitting on that hyphen of the 94V OMRC. So yeah, there is some corrosion around here. There's a little bit sitting under that cap. That's the backlight driver, but again, we're not at that point. A little bit on the metal frame. At this point, I'm kind of going with 50% likely there is some sort of cap short. So it's sort of like a, yeah, that's kind of wishful thinking. Okay, flip side. I had an iPad last night that came in with a 500 milliamp constant current draw and no turning on, and I was very lucky. It was a VDD main short, and it was the crack was on the cap, and it was facing upwards rather than being on the underside. That was just pure luck, that one. Okay, all this dust is actually making it difficult for me to see if there are cracks, so I'm just going to give it a blast. And if I can't see anything visually, then I will switch over to starting to pull out the probes and check around. So it could be one of the LDOs, it could be a failed 3215. There's a lot of things it could be. 3217 rather. Seriously, why is everyone pinging me today? And that 3v8 looks messy area. Wonder what kind of dust this is, because it's surprisingly disinclined to separate from the board. I still think the Wi-Fi might be our best candidate, but we'll see. So we're getting into the PMIC area. Usually if you have a PMIC fault, it does tend to present itself as a far more rapid cycling. Not always, but just usually. Is the other PMIC area. It's kind of frustrating that these machines have two PMICs. And usually if one goes wrong, then you kind of got to take both out. Yeah, this dust is just nasty. Hmm. We'll just see what PP bus is. Oh, okay. Wait, no. I'm an idiot. I've got ground over here, and I was pressing on ground. God damn. Yeah, PP bus is fine. Well, the main rails are looking... no, it's not actually. It's the suction pen that is running. Gee, you people have good hearing. Okay, gym cam time. Just to see if anything unusual is showing up. I'm kind of curious to see whether it comes back to here again. Nope. I'm looking for where that 400 milliamp spike might be coming from. Nothing's showing up. Might have to give this a cover over. That lower section being warm is correct, because that is the 3217 that's taken the input. What bothers me here is that we've got a little bit of warmth on the CPU or the SoC, whatever you prefer to call it. It could just simply be that it's picking up the ambient room temperature. But I'm struggling to see anything really jump up. I think that Wi-Fi module's... oh no, it's on the other side. No, nothing's really jumping out. And that's a problem. Hey there, Miles. Alright, okay, well, now we're going to have to deal with going step by step. Hey, Shad. Let's see what do you want. we're on 2020. Crap. Okay, so for the 2020, let's see, we've got solutions, 20 volt startup sequence here. So we're just going to work our way through this list bit by bit and hopefully come up with an answer. So we're going to have to start with, okay, we are on the right port to start with, and then you're not going to really see it. Basically, I'm going to, once I've done that test, I jump to the next one. Where's my notes and solutions? Once I've done that, jump to the next, jump to the next, jump to the next, yeah, so on and so forth until I hopefully come up with an answer. So we'll go above. Maybe I can add the schematics in here somehow. APRH. Alright, so first on our list is USB-C 1. We're in voltage mode for this. And since we're in voltage mode, I can just hook this up to the ground. Then we only have to have one probe to worry about. Okay, 1.6, that's about right. Five volts. 3v3 LDO. Which one are you? The bottom one. 3v3 is good. Okay, it's good. Yeah, we're already checking that. I think I've got the wrong one here. Let's try this. Yeah, I was on the wrong one. Whoops. Okay. That's fine. Okay, we did 3VO. Okay, we've done that one. What the hell? What's this? Oh, right, it's just the other side of the fuse. Okay, we've got 12.3. Then drops, 12.3 drops. Wait, I got the wrong test pad? I've got the wrong test pad, I think. Yeah, okay. Charger gate. 10.5 volts. That one doesn't come up yet. Okay, 12 volts. In here. Oh, right, it's over here. Whoops. Three. Charge enable. Geez, they're way too small. I might have to switch to microscope for this one. Have to switch to microscope. Well, we've got something there anyway. That there is 3V8A on. We've got something there. And then 3V8 way over here. And we have 3V8. Hey Copaz, been a while. Okay, power is now being supplied to the PMUs. Ah, right. Damn it, now I'm going to have to take the stickers off the PMU. Ah, that sucks. Alright. Not a fan of sullying up boards, but you got to do it. Maybe we'll find our problem down here. We'll take off the slave one as well. I'm just going to have a look at these angled on. Hey, Teresa. I have had a few cases where one of these tiny little puff caps can be failed, but failed with like 20 ohms or something ridiculous like that. So it's not, doesn't show up as a short, at least not very clearly, but it is enough to disrupt the PMIC. The PMIC notices things are wrong and shuts things down. But as I said, it's not really displaying shorted PMIC behavior. And we have 3V8, so all this section here is fine if we've got 3V8. Unless, of course, one of the phases of the 3V8 is bad, in which case it might not. Oh, we've got a bit of corrosion there. Check that out. That is, like I said, one of the areas that always gets hit. Oh, wow. Brush it and it still didn't do anything. Okay, well, we definitely know there was corrosion on that part there. Because we saw it. Another good reason for having the camera. Hey, Paul Hal. So we've marked that as a suspicious potentially. What's going on with my phone? Oh, Mr. Paul Howe, you should be sleeping, not sending me contributions. Thank you very much, Paul. Paul Howe just sent through 100 Australian dollars, which is, as always, going to be put to various uses. Thank you again, Paul. Really, I mean, like I said, if you can find another streamer that you feel can be helped, I would certainly be happy to see you do that. In the meantime, I'm more than happy to thank you every time. This is really frustrating. So I'm wondering, would that corrosion be enough to cause the issue? Now, a lot of people say, well, just replace the part and see if it is. But the trouble is, I hate the process of starting to replace parts before I am convinced that it is actually the fault. It's just one of those things where I feel like once you break the seal of the board, it's very easy to go downhill very fast. I'm just going to run it on the infrared again, just to see if anything new shows up now that I've taken those shields away. I'm going to turn off the lights too. Will say that is the downside of daytime work like this, is that it does require a bit more work to get things to show up on the infrared camera. We'll just throw a cover over and see what happens. Okay, Thunderbolt chip is a little lively. I'll just bring the current meter in next to it. Yeah, this is tricky. I said that 500 milliamp spike concerns me, and like I said, the fact that the heatsink is warming up ever so slightly. So not a lot, but it is a little bit. Normally the heatsink should tend to be Just a little quieter than that. But it could be my perception. Please don't be accurate. Okay. It's just a reflection at this point. That's not actually the CPU having a hotspot yet. But there is a bit of warmth down the bottom there. And you go, well, is that legit or is that something else? So the easy way to find out is you just pull the plug. And it's just a reflection by the looks of it. We didn't see that reflection before because obviously we didn't have the heatsink missing. Okay. And you can see why it would be a reflection because, yeah, it's got this gold trim around it, so that's why. Okay, did I just see something fade out up above the CPU just then? Yeah, there. Just above the CPU, just there. That. What's that? It comes up with the current. So it could just be a normal thing, but it is interesting that it's the only thing that we've got that's doing any kind of following of the current. It might be our hope. It's just slightly above the hole. Okay. Yeah, the heatsink was covering it. Okay, this thing. But like I said, it could be normal, but there is a little bit of a, I don't know if you can see it, but there's a little bit of a wet spot there. Okay, schematic. You're a ROM. Oh, Joy SCP ROM. It could just be. I hope that hasn't failed. Can't see anything else. If we're lucky, maybe it's the cap. Unlikely, but... Well, it's not the cap. Okay, we've got a few diode mode measurements we can make up here, so I'm just going to go around and check these and see how it looks. Okay, so 353, good enough. 275's over here, good enough. 275 up here, good enough. In fact, it's 275 all the way across. Yep. 329. Yep. 337. Yep. Okay, they're all good. Why do I get the feeling that... So we don't actually know if this is faulty or not. All we know is that it just sort of showed up on the infrared, but it is kind of weird that it would glow relative to anything else. It's not the sort of thing you would expect to glow up. Hey Greg, let's have a look at an edge on. Yeah, feels like something's under there. Well, it's kind of weird. Even if something was under there, maybe it's a very weak short to ground between pin 1 and the center pad, assuming it even has a center pad. Might not. Hey, GD Tech. Let's see. Pin 1 is... Oh, yeah, pin 1 is ground, and it does have a center pad. At this point, it seems to be my only sort of thing, unless... I don't know. Whoops, sorry about the voice jump. I am somewhat disinclined to believe it's the fault. I have a feeling it might be just a case of it's glowing up just as it's being queried. It just doesn't quite feel right, and it doesn't explain the 500 milliamp spike. And it's not really running hot, although it does have a bit of an afterglow, doesn't it? I don't like the way this is running. Like I said, once you take these things off, then it does tend to be downhill from there. I have never actually removed one of these particular ROMs before. So I don't know. I can lift it, have a look. It's in a fairly sort of heavy grounded area, so it would take a fair bit of heat to get it out. I think what I might do is UO 500. Trying to think when that comes into play. So it needs 1 V8 awake and 1 V25 awake. Hey, computer repair. Yeah, 1 V8 awake and 1 V25 awake. Now, at the moment, those rails are looking normal. So I'm going to actually go back to, we'll put power on. I'm just going to flip around a few more times. It's just weird because we don't have even 20 volts yet. So that's kind of the strange thing in my opinion. But to be fair, I don't know if that particular rail, that particular chip should be coming up at that point. I would have thought it'd be a little bit later. I would have thought it would have been in the, once you get the 20 volt stage. Hey, smeller. Anyway, let's see. We have this point here. Okay, VDD. Am I in diode mode? No, I'm in volts mode, aren't I? Yeah, volts. Yep. .5 for VDD P CPU awake. That's actually low, I would have thought. Not looking good. I'm pretty sure that's meant to be a little bit more than 0.5 volts. I hate it when they don't actually show you what their expected values are. I mean, I could be wrong. I'll get a donor board. I'll get my reference board and see what it says. But the reference board will be probably run at 20 volts, so we can't really make a direct comparison. Okay, so this is the donor board. Not donor board, the reference board. Okay, 0.6, my bad. Okay, so 0.5 could be valid. Okay, but now it's gone 0.9. That's just the CPU booting up. So 0.5 could well be valid. Okay, we'll continue on in that case. Let's see if it tries jumping around at all. Okay, so it jumps up to 0.7, then drops back down to 0.56. Okay, why do you not? If only you had a short killer, right? Yeah, kill the whole board. Sounds good. Okay, GPU awake. Okay, GPU awake is a bit of a concern, but then again, it might not. But it's coming up almost as nothing. God damn it. Okay, do we have our... Let's see if we're even getting 32 kilohertz somewhere. Let's see if I can not botch this one up. Okay, frequency. Can we get 32 kilohertz, please? Okay, it's all over the place, but there's definitely something registering there, and it should jump down. Oh, our current thing has changed. We are stuck at 30 milliamps now. No, we're back. Maybe it's because I put my probe on the oscillator. Since it wasn't a scope, it does tend to have a bit of a loading effect on that. I don't know, Joseph. Sounds like there could be terrifying budgie shorts, budgie smugglers. Okay, so we don't get VDD GPU awake. Let's see if we get SoC S1. So I've got a test point for that somewhere. There we go. Ah, frequency, buddy, frequency. I mean voltage. Come on. 0.65. What? Sorry, please stand by while I proceed to be an idiot here. It's entirely normal and fully expected. Okay, we got one V8. That's one V8 S2. This could well be a dead SoC. It's certainly looking like that. .9, that's CPU SRAM awake, 0.9, okay, that seems valid. Next up is VDD DISP S1. I don't know if that means display or what, but .7. Next one, this is DCS S1, 0.6. eCPU awake coming up. That's this one. Seems there. Let's see. Okay, we got one V8 awake coming up now. So these are the ones that we wanted for the ROM. Where was that test point? Is that you? Yeah, 1v8 there. And 1v25 was the other one that the ROM was looking for. Okay, it's this one here. And 1v25 there. So it's kind of weird. I'm kind of thinking that the ROM is okay because those rails don't take a hit. Ben, what's this? You got Pezio beeper rated at 3v3 with a maximum input of 30 volts. Yeah, Pezios are kind of funny things. I got a cough. Is it legit a Pezio or is that a magnetic buzzer? The main thing is trying to drive the capacitance of those things can kind of really mess up your driving circuitry. 2v5 awake NAND. Okay, we've got 2v5. Oh, it's legit Pezio. Okay, yeah. Yeah, I don't know what to suggest for that. I guess if it's rated at 30, you probably could, but you're probably not going to get a huge amount of increase in output. I'm assuming that's what you're trying to do. Let's see, we got 1v06, and we got that. OV74, what a weird value. And yet it's 0.8. Oh well. Let's see, 0.6. 0.6 it is. Probably should get this meter calibrated just in case I'm drifted off. Not that it really matters for these sort of things. Yeah, 90% of the time you're really looking for present, not present type situations. Let's see, I get that. What's that? Okay, 1V. So this is, we're in the S2 state. Let's see, where are you, you filthy cluster? This is going to be 0.88, yep. It's a lot of jumping around. 0.75, yep. 1v2 PLL. Wrong one. Yep. I don't know what this is, but it's kind of... Is it 0.8? Yep. Another 0.8, yep. And 1.2, yep. Okay, now we've got 1v8 awake. And I have a feeling we're probably not going to see this one. Hey, babe. Oh, thank you. Just, yeah, throw it on the floor. That's good. Okay, so we do get 1v8 awake. Oh yeah, we did measure these before, didn't we? Yeah, so we are getting that 1v25 awake as well. Alright, I'm really starting to feel a little bit lost now. Hey MacGyver. Ben, that's probably like 50% duty, driving duty. And so if you go at a much lower driving duty, maybe. I don't know. Don't ask me. What do I look like? A person who knows anything? 0.6. Okay, that's supposed to be 32 kilohertz clock. And it seems like it's there. Yeah, there we go. Smack on too. That's for the SoC. And we do have a 24 megahertz clock. Just up here. Don't think we're going to see anything on that. It's all over the place. We'll bring out the scope, the DSO for that. Man, really? Ping, ping, ping. Okay, stand by while I answer this. Afternoon, I have a MacBook M2 not charging. Is there any chance you'll be able to do any repairs and get it up and running? I'm happy to. Would be happy to have a look at that, full stop. Okay, sent them the link. Yeah, it's a little weird. I don't know what's going on here. I don't know why we're not getting our 5 volts. I mean, could it just be a simple bad 3217s? I don't know. Okay. It's actually surprisingly infrequent for me to diagnose anything using the sequences. It's like, yeah, great, we got all our stuff, but still can't fix it. I hate this. I never get a good ground on these things. Auto. Interestingly, we're not actually getting anything. Could be maybe a bad choice of ground. Definitely power coming through. Okay, we've got that weird thing where it's doing that partial pulsing again. Just reset it. Okay, yeah, it does not like me loading up the... It does not like me loading it up. Oh, it's on 1 by? That's why. Idiot. Okay, Paul, you get some sleep. Best of luck to you with that. Okay, let's try it now with the 10 by. Okay, at least it's not crashing it out this time. I need to find a goddamn ground. Is that my mama? Okay, we do have something here. Yeah, okay. We do have our 24 megahertz. Frequency counter would have been easier, but using motors as little speakers is certainly a very amusing thing. Like, it was quite confusing the first time I encountered that. Like, we used to do it on brushed motors and then do it on brushless motors. It was a handy way of getting a audible report without having to actually put a speaker anywhere. Let's try something that maybe I should have tried right at the start. Put some lights back on this room. Now this unit, I'm fairly sure, does not actually have the values for this particular board, but we can sort of still have a look and get some sort of estimate. We'll try 2159. Maybe not. 2179. Yeah, nothing's out of range on that or anything, so it's not on the input stage of the USB-C. This is very annoying. Anyone want to throw some wild theories? Because it's certainly becoming annoying, that's for sure. Third cap from the left. Very good, Teresa. Like I said, the only spot of corrosion we had, funnily enough, the XEZ actually does have a better 2020 board diagram. What? There we go. Ah, every time. Right, 1780, 1780. Let's try and load that up again. Yeah, it's a rare thing where the XZZ has, its PCB version of a MacBook board actually has superior layout, and this one does. Okay, so we had a bit of spotter corrosion on PB bus A on 3V3S2. Interesting. Hey, mime, a DEFPOM? Yeah, working the day shift, have to. Josh, yeah, that's possible. Like I said, we had a tiny smidge of corrosion here. Now I'm going to bring in the OB data values. I'll just switch over to schematics here. Select download. Okay, so we've got our OB data. And okay, so we've got some diode mode values up here I can work with. Hey, Lolo. So you can see the pink chip. Man, I am having trouble focusing properly these days. Okay, so this here, we want 0.5. 0.47, so that's really pretty much on there. Let's see if we go back to the schematic. So that's just supply. So what's this pin here? 3V2, we do not, what have we got? Okay, we got 0.43, 42 rather. Yeah, that's close enough. So yeah, the fact that that had a little bit of corrosion on it, was it fatal? I don't know. It was only a very small amount, and it really did look like surface corrosion more than anything else. And the other thing is, on here, it's not like it's in any of these critical points, it's just simply a rail, so a little bit of corrosion there shouldn't normally cause big problems. Let's see if we actually get 3v3S2. I have a feeling, you know what, I'm not going to guess. Let's just see if we do. Yeah, we've got the voltage output there, so let's have a look on the schematic. We'll take that one. Okay, so the enable must be working, feedback must be working. There is, okay, so we've got current sense, and it must be fine, otherwise it'll be shutting it down a lot quicker, I think. I cannot really think of a, okay, so that's soft start, so it should be fine. I can't think that that's going to be the problem. This is getting real frustrating, real fast. Like, we don't even know, we don't know anything. Okay, I'm just going to take another look at the edge. Hey Ryan Labs, just losing my mind here. Nothing out of the ordinary. like I said, the worst damage we have is along here. A couple of those little puff caps got some bad corrosion on them. But everything else looks pretty standard. Let's have a look at what those little puff caps are on the... So up here. Ach nee man, what? Jeez. That is... Okay. I'm just going to see what that is. Hey, Mimi. What have we got there? Sorry. Cash, is it? Sorry, it took...
Yep, that seems about right, Ellie. Yep.
Straight away. Sorry. Get a bit stuffy in here. Right. Okay, right, yeah, we're trying to work out what these are. So this is 3V3S2. And that will just be, yeah, coming off here. So if there was a problem with those caps, if one of them was shorted, we would have already detected that. I think I'll double check. It'd be funny if that was shorted, but I very much doubt it. Not diode. Continuity. That's why we go beep initially. No? Yeah, 2K, definitely not a problem there. So I'm focusing on this area just simply because, well, that is where we found the corrosion. So there may be, and yeah, we found a little smidge there. Like I said, this whole section is 3V8. We know that works. I really don't know how to test and verify if that ROM is a problem or not. And I certainly don't want to do anything like, hey, let's just swap the ROM and see what happens, because that being matched with the board, chances are if you swap that ROM, you'll probably trash all your data. Even if you swap it back, I think when it comes back, it will be trashed. And I don't know if that 500 milliamp spike that we see, I don't know if that is an actual short or whether that is just it trying to fire up and then immediately shuts down. So yeah, this is a difficult one to hunt. There's a little bit of corrosion there on the H2 chip. See that top left pin? Yeah, whatever this stuff is, it's really weird. It's like I have to brush it first and then I can knock it off with the air. So it seems like it gets stuck. Yeah, there's definitely a little bit of corrosion on the H2 chip. So we'll just pink mark that. Using the pink mark is very handy because it is a color that shows up extremely quickly when you're looking over a board. Unfortunately, we don't have a history on the board either, so we don't know whether the person was just using it and it died or what. We've got nothing. So I might have to put this aside, do something else, come back to it later, like query with the shop and say, look, can you get a customer history on this one? Can you advise me what led up to it? Were they using an original charger or a generic charger? If they were using a generic, then my focus would switch back to the 3217s. And typically if we do have a shorted cap in here somewhere, it should at least give us some glimpse if it's the cause of that little 500 milliamp spike. Because 500 milliamps at 5 volts, it's going to give you 2.5 watts. And 2.5 watts on a very small package is definitely going to glow. Smidge of corrosion on that test pad. Alright, let's have a look at what that H2 pad that we marked, see if that has any, see if it seems like it might have any relevance to not booting. It's this one here. Display backlight. No, it's going to have nothing to do with it. Ah, well. Okay, one last shot of the infrared camera, and this time we will use a different port. So previously we've been using the standard port that we use for testing. I'm going to use the secondary port. Who knows, maybe something different will happen. I would love to see where that spike is coming from. You're going flat on me. No, you're not. You're alive. You're just not responding. And you've stopped responding again. Don't be like that. So we can see the Thunderbolt chip is slightly warmer, which is correct. It's all good, Greg. We're all on lurking. Oh boy, the reflectivity of the shields is such a pain. Where'd that USB... There it is. It's not so much the camera dropping frames, it's my software not parsing the data stream properly. And I think it was because it was going flat. It's just turned itself off now. So yeah, I think it was because it was going flat. I really just need to have this camera hooked up to a 5 amp hour battery or something. It is the downside of these FLIR cameras, is they do have a habit of, after a couple of years, their batteries just completely go to crap. I think I can adjust the emissivity sensitivity a little bit with the software, but I don't think it's going to be as good as what we want. Easier just to throw a blanket over it. I need a dark box or something. Okay, we can see that ROM again, but it never actually spikes. Like, it warms up but doesn't spike. Well, what now? Yeah, DEFCON, you're talking about this here. That's that's one of the ROMs, and it is a point of concern, but we're kind of doomed if it is that. Like, if it's a faulty ROM, then we're kind of doomed because that contains some critical information. The bottom left down here, that's the Thunderbolt chip, so we are expecting that to get a little bit warmer. The problem is this spike here, this one here, this is the one that I can't see where it's going. I'll flip the board over now. Something's blocking the view there. And usually those crosshairs will jump to a hotspot, even like a quick hotspot. They will jump, assuming that it comes out. It bothers me that we have warmth under the... Yeah, it bothers me that we have warmth underneath the SoC or the CPU, whatever you want to call it. I don't know, man. I just can't seem to see where that spike is. Like I said, there is this warmth under the CPU. Nothing stands out. Hey, Fox Laser, morning. It'd be nice if that spike showed up elsewhere, as in more frequently. It certainly is not a frequent occurrence. It's like it's three main areas. It's like this here, this, and this. Now these two could just be reflections. Okay, I just saw something pop right there. Just by sheer fluke, something popped right there. But it could have just been pure luck. Pure random. Just that, yeah, there it goes again, but that's... With chilling the board, it's a the trouble is the way I process this data is in a relative mode. The other problem is that it is so warm here that I mean, I suppose I could put it in the fridge, but it's really not going to make much difference. Our biggest problems are reflectivity, which I can see there now. That's one there. This is somewhere where we saw that little spike. So I'm going to investigate this area here. So what have we got over here? Funnily enough, a ROM chip. Certainly nothing there that I would... I might just throw this into my own chassis and see if it changes behavior. So we want 2338. As you can see, this is a very easy way to waste a lot of time during the day. It's not a good thing to only get one machine done a day. If that. At least this one's got a battery cable. It is crazy how the camera actually looks better without the artificial light. Like, this is just indirect sunlight coming in, like ambient sunlight, and I feel like visually it's a better video capture. But then I put on all my lights and it feels kind of substandard. You know, there's too many highlight. Yeah, it's not as good. Hey GD. Okay, so this is my board with a proper battery. And I'll probably, yep, I've forgotten to bring these ones up. Now, what I'm partially hoping for as a miracle is that it just simply has a bad battery and got itself into a DFU mode, or they put it in a DFU mode, and now it's just all weird. It doesn't know what it's trying to do. Yeah, lots of assumptions and theories there, I know. But at this point, I really don't have anything good to go hunting on the board. Any sort of changes I make, like removing chips or things like that, are purely going to be... It's not even guesswork, it's just hoping for the best, and I don't like doing that. I would personally prefer to not do anything to the board and have them hand it off to someone else who might find it straight away. Yeah, and at least then I haven't messed with the board. Speaking of which, I need to get a screw for this. 2338. Yeah, so I'm basically trying to be kind to the next technician. Have your lighting set to 5,000. Yeah, these are 5,000s. I do have some 4200s above me, just as backlights, but they don't have, they don't have a massive intensity about them. Okay, let's see what happens. Interesting, we've got 400 now. We're still restarting, but we've got 400 constant. Ooh, we're not even restarting normally. What the hell? Add an Apple logo. What the? Okay, so let this be a demonstration to you all, and I'm serious about this. This is why you don't go fucking around and pulling chips. Eliminate all your other possibilities first before you go, let's just pull this chip. Because look at that. It's bloody well working. Yeah. My fault there too, because basically I ran on the assumption, okay, they have tested it. So it's in recovery because they've been butchering around with it. Yeah, I don't know why the meter froze. Actually, no, it's back again. There is still something amiss, but if this person is just after their data, there's definitely something amiss there, but worst case scenario, I can charge up. Yeah, the current stops. But the point is, at least I can get their data back now. Ooh, maybe I can't. What are you doing, little man? Yeah, but at least now we've actually got some kind of hope. Yeah, that is really weird that the charge stops. It is an original charger. I'm running off a Apple 140 watt. Okay, well, at least we know it's booting. Something quirky going on. Maybe that looks seriously offset. But this flex here, relative to where the battery is, probably should put the, okay, I probably should put the heatsink back on, but it will survive. It's not like it's an AMD from the year 2000. Those things were fun. Didn't get the heatsink on perfect and bam, they're dead. There's definitely something weird. Okay, well, we've got a start, so that's good. What I'm going to do, I'm going to put my iCloud lock donor on there. And then we're going to make sure the battery is fully charged. It definitely, yeah. So we know it boots. It starts trying to boot. We're sitting in recovery mode. Oh yeah, we'll put the... Sorry, heat transfer post, you're going to be imperfect, but you are for data recovery only at this stage. Did you clean those two caps up by the IC? That was the Wi-Fi. I did not. No. Oh, I wonder if it's backlight that's crashing out. I have to check that. Because if it's backlight crashing out, then we know the chip that's at fault. Because remember, it was that one that had a little bit of corrosion on it. Could be a bad ISL. Okay, this is the known working iCloud lock donor. No, not donor, reference board. Maybe when Wi-Fi, well, yeah, that is possible, that is possible. Might be able to test that, because when it's in recovery mode, you can actually turn on and off the Wi-Fi. Why are you being difficult? There we go. That's fine. Battery screw. Okay, so this configuration basically has nothing to do with the customer's machine at all. There's no battery, nothing is from their machine. But I just want to be seeing what the battery state is on this one. Unfortunately, this is iCloud locked. Did you hear about our first rocket? Yes, I saw that do about its 22nd attempt and then dropped. Okay, we're at 100% battery. And like I said, this is my reference one. Unfortunately, iCloud lock is a very real thing these days. Select a Wi-Fi network, yep, whatever. Yeah, you're right about that, DEFCON. I just was wondering about, I wanted to have a look at the thing. It gets stuck at 5 volts. So the battery is what is powering that one up. So we could have an ISL issue. But at least we know this is now 100% battery. Good thing that's a piece of plastic. Just about broken that speaker now. At least I'm getting closer, yes. Well, at least we didn't screw around with that ROM. By the way, the ROM is actually not obscured by the heatsink. The ROM is visible. Just notice that. Ah, come on. 2 out of 3 is not good enough. What is curious is that it's holding that 400 milliamps. So I'm wondering if we've got a bad, yeah, like I said, bad ISL. So it's holding that 400 milliamps that would normally would spike. So yeah, bad ISL or bad something with the charging circuit, I'm going to guess, for now. Yeah, come on. Because I know there's some businesses out there that 10 minutes into it, they would have went, nope, that's it, get rid of it, throw it out. No fix, $100 please. And you know what? That's definitely a far more profitable way of doing this business. And then you just invest all the extra money that you make into better marketing, telling people how great you are. And once you've done that, people will send you stuff and you can then go, well, no fix, no fix, no fix. And you're a winner. Yeah, it doesn't go to, it's definitely stuck at that 5 volts. And boom, just drops off, disconnects it. See if I can actually start this. What I might do is plug it in and then pull it out. It's not even wanting to play that game today. Okay. Nope. Actually, nothing comes up on the output here. Alright. I am going to stop at this point and I'm going to go and ask some questions and have a look at the schematics and, you know, just sort of, well, the main thing, ask some questions. I'm going to say, hey, has anybody else had this problem whereby you won't get 20 volts, but it will boot it and it will disconnect the USB-C. And just see if anyone else has experienced this one before if no one else says anything, if no one comes up, oh yeah, it's the ISL or whatever, then I will dive in and start. So basically I spend a lot of my time trying to avoid doing work, and yet somehow I end up doing more work. But because this is data recovery scenario, I don't want to get over eager with part replacements and end up causing trouble. Like imagine if we'd pulled that ROM chip off and started messing around that. It would have been to no avail and we would have risked losing the data. So it would take a little longer, but hopefully we can get to the point where we can get this person's data. SMC reset, we shouldn't need to. I don't think you can even do that on the M1s anyway. How can you tell when the ROM goes bad? It probably wouldn't even boot, I'd say. Or it would come up in a locked state, as in iCloud lock type thing, but I don't think that's the situation here. I feel like this is either a bad, one of the MOSFETs are bad for the charge circuitry, or the ISL itself is bad. So, alright then, that's it for me for this afternoon. It's 2:30. Time to go to the dentist, 2:30. I am going to go get myself a cup of coffee, work on this in terms of looking at schematics and asking around. Then I've got some more boards to build as well, because we sold out of all the USB-C meters. I made 8 last night, they're all sold, so I'll make another 4 a little bit later. But for now, I need to go take a break, kind of spend a little bit too much time on this. What has that been now? 2 hours. Yeah, it's a bit too much, but hopefully we can get a win. So thank you all for watching. I'll see you on the next one. It might be a little bit later this afternoon. Probably won't be tonight, because like I said, I'm trying to avoid doing night streams simply because of the fact that I am needed to be another pair of eyes and ears outside, particularly with new things that have come about. So thank you again for watching. See you on the next one. Till then, you all take care. I'll see you around.